All right, characteristics of quadratic functions. It says here today you guys are going to be identifying some characteristics of those quadratic functions and compare and contrast the two representative algebraic forms of the quadratic. Now those two forms are the ones that we saw yesterday. That is the standard form and the vertex form. Those are the two that I showed you yesterday. Those are the two that we're going to be working with today. So up at the top of your paper, you'll notice that we have both the vertex form and the standard form, just in case you don't remember the equations from yesterday. Now it says here that A, the B, the C, the H, and the K represent some constant. They represent some number. But the A cannot be a 0. Why? Why can't we have A be a 0? What would happen if A were a 0? Anybody want to take a guess why A can't be a 0? Well, let's talk specifically about this one right here. If A were a 0, what happens when you multiply anything times 0? You get a 0, right? I tell you what, it's better if we look at an actual graph. Everybody go to the calculators for me, and let's try doing this. Let's do y equals 0x squared. I don't know, let's do plus 2x, and let's do c, make that a 3. So let's type in 0x squared plus 2x plus 3. And let's see what would happen if we were to use 0 for a. Graphically. What do you notice about the graph? It's just a line. Notice it's no longer a quadratic. It's no longer a U-shape. What do you need to have in order to have a U-shape? That's exactly why. In order to have a U-shape, you got to have an x squared. And if you're multiplying by 0, you're not going to have an x squared. Okay? So, right here, down at the bottom, I want you to write down for me. If a were a 0, then you would no longer have an x squared. And if you no longer have that x squared, well, then you no longer have a quadratic. What you have is a linear function instead. Okay? So it's important that a not be a 0. It can be any other number. It can be fractions, it can be decimals, it can be negative numbers, it can be positive numbers. The only number that it cannot be is a 0. Now keep in mind, it's only the a that can't be a 0. B can be a 0, C can be a 0, H can be a 0, A can be a 0. The only one that can't be the 0 is the a. Because that would result in a linear function rather than a quadratic. And notice that would also go for that vertex form. I only showed you the standard form, but that would also go for the vertex form as well. You can't have an a in that vertex form either. Otherwise, you'd end up with a linear function also. So that's our only restriction when it comes to the letters. The letters can be any number. The only restriction we have is that a can't be a 0. All right, so now we're going to look at finding a couple of things from the vertex and the standard form. So here's what we're going to be looking for today. We're going to be looking for that vertex we just talked about, the axis of symmetry, that's that line that cuts the U shape in half. We're also going to be looking for the Y-intercept. We're going to be looking for the point that's symmetric to the Y-intercept. In other words, what's the point directly across from that Y-intercept? And we're also going to be looking for the X-intercepts. Now, how we find that stuff is going to depend on which of the equations we have. If we have the standard form, this one right here, in order to find the vertex, we have to do this. To find the axis of symmetry, we'd have to do this. To find the Y-intercept, we'd have to do this. On the other hand, if we're given the vertex form, to find the vertex, we'd have to do this. In order to find the axis of symmetry, we have to do this. And to find the Y-intercept, we'd have to do this. So how we find those things are going to be a little bit different based on what equation we're given. Now you'll notice the last two over here, we can find both of those things the same exact way, regardless of which equation they give us. All right, so that's what we're going to be doing today. Now, I'm not going to be doing both of them at the same time, because I think if I do both of them at the same time, I would just be confusing you guys. So what I'm going to do instead is, I'm going to start with the vertex form first. Once I do all the vertex form, then I'll come back to the standard form. I don't want to do it at the same time because, like I said, it might confuse you. All right, so here we go. First of all, the vertex form. In order to find the vertex, it says we're going to use H and K, which are these values right here in the equation. That's the H and the K. The axis of symmetry is going to be equal to X equals H, and the Y-intercept is going to be the order pair 0, some number. And we can find that number by plugging in 0 into the actual equation itself. And I'll show you how to do that with an example. The last two, we're going to cheat there, and we're just going to use the calculator to get the last two answers. All right, so here we go. Let's go to that examples that we have there. Now we got two different ones, two different equations. The first one here is the standard form. The second one we have is the vertex form. So this right here is the one that we're going to be looking at. That's the one I want to use. So the first thing we're going to do is we're going to find the vertex. And if you look at the notes, it says the vertex is going to be H, K. That's what it says in our notes. So I need to write down what the H is and what the K is. Now here's the only tricky part, or the part that you're going to have to be careful. Your H, or the number that's inside the parentheses, you're just going to have to make sure you use the opposite sign. So in other words, instead of me using a negative one, what we're going to use instead is a positive one. That's the only part you need to be extra careful about. Your K is that number outside the parentheses. It's that -4. So our vertex is going to be at 1, -4. That's the vertex. Your axis of symmetry, according to our notes, it says the axis of symmetry is X equals H. That's what it says in our notes. Well, what you're going to have is X equals H. And we already found H. H is that first number in our vertex, which is a 1. So X equals 1 is going to be your axis of symmetry. Your Y-intercept, here's where it's going to get a little bit of tricky, or we're going to have to do a little bit of work to find the Y-intercept. To do the Y-intercept, again, if you go take a look at your notes there, here's what the note says. In order to find the Y-intercept, we're going to have to plug in X equals 0 into the equation and find Y. So we're going to do a little bit of work here. So let me get this out of the way. And here we go. I'm going to take out X, and I'm going to replace it with Y. There it is. All I did was replace the X with the 0, and I want to figure out what Y is. Now you have a calculator. We don't need to do this by hand. We can use our calculator. You're going to type it in exactly like you see it. Now we're not doing it in Y equals, guys. We're just doing it in a regular old screen. Okay, so get a nice clean screen, and let's do exactly what it says here. Use parentheses around your 0 minus 1 squared minus 4. Let's see what number we get. -3. Everybody agree with that? -3. Okay. So what we're going to do is we're going to write that as an ordered pair. So 0 was the number we plugged in for X. -3 was the Y value. So our Y-intercept ends up being 0, -3. To find the last two, we're actually going to use the calculator. We're going to actually graph this so we can look at it. So go to your calculator for me, and I want you to enter the actual equation for me right here. So NY equals, you're going to type in X minus 1 squared minus 4. Make sure you're using the parentheses. What you're going to do for me is you're going to graph it. I'm going to get a little quick sketch here, so who's got it so I can copy there? Got yours. Grab this, copy. Is that the same kind of graph you already getting? Right, so that's the graph of X, Y equals X minus 1 squared minus 4. We've already found the vertex. We've already found the axis of symmetry. And we've also found the Y-intercept. And that Y-intercept is this point right here. That was the Y-intercept that we just got through finding. This one right here, the symmetric point to the Y-intercept, is the one we're looking for. So what we're looking for is this point directly across from it. The one that's right across. So look at your calculators. And I want you to tell me what is that point that's directly across from the Y-intercept. I can tell you this about the point. it's going to have the same exact y value. I can tell you right now that the y value is -3. The question is, what is the x value? +2. That's correct. So the point that's symmetric to the y-intercept is 2, -3. That's referring to this point right there. The last thing we're looking for are the x-intercepts. Now, as you can see from this graph on the calculator, you have two of them. This is one of your x-intercepts. This is the other x-intercept. Those are the two that we need. Those are the ones we're looking for. So let's start with this one right here. What is that? -1 or -1, 0. So let's write that down. That's one of our ordered pairs. -1, 0. That's one of your x-intercepts. What about that other one? What about this one right here? 3, 0. That is your other x-intercept. Now remember, we're not always going to have two of them. This one we happen to have two, so those are the two that we found. -1, 0 and 3, 0. All right, so this is how we do it if and only if we have the vertex form. It's a little bit different when you have the standard form. So what I want you to do now is turn your page over. You'll notice you've got two examples on the back. One of those is in standard form, one of those is in the vertex form. Which one of those is in the vertex form, A or B? I'm looking for which one looks like this right here, the vertex form. B. B is the one that looks like the vertex form, or is in vertex form. So we're going to work on that one, guys, and I want to make sure we have the examples on vertex form first. So everybody look at B. We're working on B. We're going to do exactly the same thing we just got through doing. Okay. B. The first thing we're going to do is we're going to find the vertex. All right, so here we go. The vertex, again, according to our notes, it says it's H and K. H. What is H? Nope, not 1, but you're close. -1. Remember we said we were going to change the sign? So it's -1. What about the K? 3. So our vertex for this graph, or for this function, is -1, 3. So here's what we're going to do. Since we're going to be graphing this, let's go ahead and plot that point -1, 3. So everybody find -1, +3, and put a dot for it. That right there is going to be our vertex. That's the point where the graph is going to curve. The next thing I'm going to look for is the axis of symmetry. I'm looking for that line that's going to cut the graph in half. And according to our notes, it says it's x equals h. Well, we already found h. It's the same number I have in my vertex over here. It's -1. H is the first number. So what you're going to do is you're going to come over here to your graph, and you're going to actually draw that vertical line from it, that axis of symmetry. So you're just going to draw a dotted line right through the -1. That's where we're going to cut the U shape in half. The next thing I'm going to do is find the y-intercept. And the way we found the y-intercept was by plugging in a 0 for the x and solving for the y. All right, so let's use our calculator on this one. That's what it looks like. All I did was take out x, put in a 0 for the x, and we're going to solve for the y. What was it? +5. So that would mean that we have the ordered pair 0, 5. 0 was the x, 5 was the y. So let me come and find that ordered pair. 0, 5 is right here. That's the ordered pair 0, 5. The next thing we're going to do is find the point that is symmetric to the y-intercept. In other words, we're going to look for the point that's directly across from that y-intercept. So notice, we got this black dotted line here. That is our axis of symmetry. That's the line that cuts it in half. So if I have a dot on the right side of that line, I should also have a dot on the left side. So we're going to put another dot right over here. That's the point that is symmetric to the y-intercept. Question is, what is that point? What is that ordered pair? -2, +5. That is that point that's symmetric to the y-intercept. Now, in order to find the x-intercepts, I got to see an actual graph here, and I don't have that yet. So what we're going to do is we want to make sure this graph is as accurate as possible. So let's go ahead and go to our calculators now. Go to y equals, and let's type in the function itself. Let's type in 2 times x plus 1 squared plus 3. Put that in your calculator. Before you graph it, look at your table. Look at your table. And you'll notice you got lots of points, lots of ordered pairs. I want us to list some of the ordered pairs that would actually fit on our graph paper here. So give me some ordered pairs that fit on this graph paper. Give me some ordered pairs. Negative 3, 11, that'll fit. What else? Negative 2, 5. Negative 1, 3. 0, 5. 1, 11. Is there anything else that'll fit? I think that's it, right? There are other points, but those are the only ones that actually fit on our graph paper. So let's plot this. Now notice some of them we already have plotted. Negative 3, 11. We don't have that one yet, so let's plot that. Negative 3, 11, right here. Negative 2, positive 5. We've already got that one taken care of. Same thing for negative 1, 3. We also have 0, 5, but we don't have 1, 11. So let's put a dot for 1, 11, which is right here. So now that I have all of these points, let's connect those points, making our U-shape. So there's our U-shape. That's our problem. So now that we have the problem, now we can answer that last question, which is, what are the x-intercepts? What do you notice here? There is none. There are no x-intercepts on this one because that graph has been moved up so that it doesn't touch the x-axis. All right, so all we're going to do is write none. There are no x-intercepts. So this is how we're going to find all of these characteristics if we're given the equation in the vertex form. Now it works a little bit differently when we have the standard form, which is the next one we're going to look at. So let's go back to the very beginning here and let's take a look at the notes. I'm looking at standard form now, that y equals ax squared plus bx plus c. To find the vertex, it says we're going to plug in x equals negative b divided by 2a into the equation and find y. To find the axis of symmetry, we're going to use x equals negative b over 2a. To find the y-intercept, we're going to use 0c. And to find the last two, we're going to do exactly the same thing we did earlier, which is use the calculator. So let's see how we do that. Here we go. Now I'm looking at this one right here, the standard form. Now, they have it vertex, axis of symmetry, and y-intercept. I like to do things a little bit backwards here. I like to start with the y-intercept. And the reason I like to start with that one is because it's the easiest one to find. All it says is to find the y-intercept is 0c. So in other words, it's going to be 0 and then whatever c is, or the very last number in the equation. And what's that very last number, the constant? Negative 3. So that right there is our y-intercept. That's all I had to do to find the y-intercept. Now I'm going to find the axis of symmetry. Again, remember I said I was going to work a little backwards here. And to find the axis of symmetry, the note said we're going to do x equals negative b over 2a. So I'm going to replace b with a negative 2. I'm going to replace a with a 1. So let's see here, a negative times a negative 2 would make that a positive 2. And 2 times 1 is 2. And what do you get when you do 2 divided by 2? 2 divided by 2 is a 1. So we're going to end up with x equals 1. So that right there is our axis of symmetry. X equals 1. So we had to do a little work to get there. Now I'm going to find my vertex. Now to find the vertex, it says we're going to take that value that we just found, the 1, and we're going to plug it in for each of the x's so we can find out what y is. So in other words, we're going to do this. We're going to take 1 and plug it in for each of the x's. Now that I've got that 1 plugged in for each of the x's, we're going to put that in our calculator and see what we end up with here. So put that in your calculator. Let's see what we get. 1 squared minus 2 times 1 minus 3. Negative 4. So what we're going to do is we're going to end up with the order pair 1, negative 4. 1 because that's the number we plugged in for x. Negative 4 because that was our new y factor. Now let me stop right here real quick. Anybody notice anything about the vertex, the axis of symmetry, and the y-intercept? How do these two relate to each other, the vertex and the standard form? Y'all notice anything? Look at the vertex on the first one. Look at the vertex on the second. What do you notice about those two? They're the same. What do you notice about the axis of symmetry? They're the same. What do you notice about the y-intercept? They're the same. Why are they the same? Because they're the same equation. They're the same graph. They're just written different, but they are the same equations. Okay? So that right there is the first two. Now remember, the way we found the last two is by using the calculator. So go to your calculator for me real quick. Go to y equals and type in x squared minus 2x minus 3. X squared minus 2x minus 3. Look at the graph. And you'll notice that graph you're getting is exactly the same thing we got earlier. It's this one right over here. Same exact graph. And what did we find the point of, or the symmetric point to the y-intercept was earlier? 2, negative 3, which is still the case. It's still 2, negative 3. Notice you still have 2 x-intercepts, and they're exactly in the same spots as the other ones. And those 2 x-intercepts were negative 1, 0, and 3, 0. So we found those two exactly the same way we did the other vertex form. So it's a little bit harder when you're working with the standard form. When I talked about this yesterday, I said the reason we use vertex form is because it's a lot easier to find some of those characteristics. And now you can see that is the case. All right, so let's go to the back page there so we can do that last example, A. Notice that A is in our standard form. And we're going to go through there and find all of those things along with this graph. Now remember, I said I like to work backwards here. So I'm going to start with a y-intercept because it's the easiest one to find. And according to the notes, the y-intercept is 0, c. 0, and then the constant, the last number. And the last number for us is a negative 2. So that's the y-intercept. Now again, because I'm going to be graphing this, I'm going to come over here and plot that point 0, negative 2 right here. The next thing I'm going to do is I'm going to find the axis of symmetry. And to find the axis of symmetry, we had to use this little formula right here. X equals negative b over 2a. So let me replace the b with a 6. And let me replace a with a, what is it? The negative 1. So let's see what we get here. Negative 6. 2 times a negative 1 is a negative 2. And a negative 6 divided by negative 2 would be a positive 3. So we end up with an axis of symmetry at x equals 3. X equals 3 is our axis of symmetry. So I'm going to come over here and draw that axis of symmetry, and it's right here. That right there is the line that's going to cut our U shape in half. That's that line of symmetry. Notice how it goes right through 3. The next thing I want to find is the vertex. The vertex. Let me see here. We're going to take the 3 that we just found, and we're going to plug it in for each of these x's. Here we go. There it is. All I did was take out each of those x's in the equation and replaced it with a 3. I'm going to put that into my calculator and see what I get. What was it? 7, which means I'm going to have the order pair 3, 7. 3 because that's the number I plugged in for x. 7 because that's the value I got for y. So 3, 7 is my vertex. So let me put that point right here. There's 3, 7. That's the point where the graph is going to curve. Okay, the next thing I'm going to look for is that point symmetric to the y-intercept. The point that's symmetric to the y-intercept. In other words, I'm looking for the point that's directly across from this red dot that I have here, the y-intercept. So where would that fall? Well, look, I'm 3 units away from that axis of symmetry, so I'm going to go 3 units in the other direction. So that would put me right there. That's the point that's symmetric to the Y-intercept. And what is that point? What is that ordered pair right there? 6, negative 2. So write that down for me. That is that point, 6, negative 2. Let's go ahead and get the graph now. We're going to use our calculator to finish it up. So go to your calculators, and in y equals, we're going to type in negative x squared plus 6x minus 2. Just like we did earlier, we're going to go to the table, second graph, and we're going to list some points, list some ordered pairs that are actually going to fit on our graph paper. Now, some of them we may already have here, but that's all right. We want to list them. Negative 1, negative 9, that would fit on our graph paper here. What else? 0, negative 2, which we have already. 1, 3. 2, 6. 3, 7, we got that. 4, 6. 5, 3. 6, negative 2, which we have. 7, negative 9. And I think that's all it fits. So some of these we already have, some of them we don't. So let's go ahead and plot the points. Negative 1, negative 9 would be right here. 0, negative 2, we already got that. 1, 3 would be this point right here. 2, 6 would be this point right here. 3, 7, we got that one. That's our vertex. 4, 6 would be this one. 5, 3 is this one right here. 5, yeah, we got the 5, 3. We got 6, negative 2 already. And now we need 7, negative 9, which is this one down here. So now we got all the points. All we got to do is connect those points. And that's the U shape we get right there. So now we're ready to finish it up and list the 2 X-intercepts. And we do have 2 X-intercepts. They are right here. We got this one and this one. Those are the 2 X-intercepts. Those are the ones we're looking for. What are they? Can you tell what they are? Is it at 1? No. It's close to 1, but not exactly 1. Is it at 1/2? Not quite either. So how are we going to find it? I need the exact point. Well, we're going to have to cheat a little bit, guys. We're going to have to ask for some help from our calculator. So just real quick here, because we're running out of time, let's go to your calculators and let's go to second trace form. Second trace. And I want you to look at number 2. Number 2 says zeros. That's what we're going to be finding. The x-intercepts and zeros are the same thing. So I want you to select number 2. And I want you to notice down at the bottom of your screen, you have something that it says. What does it say down at the bottom of your screen? Left bound. What they want you to do is move to the left of one of those zeros, or the x-intercepts. So what I want you to do is put your little cursor. You're going to use your little arrow keys to move your cursor. I want you to put the little cursor somewhere around that area. That is to the left of our x-intercept. So move your little cursor so that it's right in that area somewhere. Once you're in that area, I want you to hit Enter. And now notice, instead of saying left bound, now it says right bound. So now what they want you to do is you move your cursor again. Move it up in this direction right here. Once you're in that general area, you're going to hit Enter again. And what does it say this time at the bottom of your screen? It doesn't say left bound anymore. It doesn't say right bound anymore. It says yes. Right now it says yes if you've done everything correctly. What they want you to do is move your cursor so that you're somewhere as close as you can to that x-intercept. So just get it as close as you can to the x-intercept. Once you're as close as you can get it, hit Enter. And now it should give you the actual answer of the x-intercept. Down at the very bottom of your screen, you're going to see 2 numbers. You're going to see an x value, and you're also going to see a y value. What is that x value you see down at the bottom of your screen? The decimal. And that's okay. That's what you should be seeing. What is that decimal? Should be 0.35 something something something. It's some long decimal. Well, we're going to go 2 decimal places. So we're going to write the order pair as 0.350. And then, of course, we'd have to go through that same procedure again to find this other x-intercept. But we're going to go ahead and stop there because we're out of time. We'll look at some more of that tomorrow.